this is Pre-Algebra Lesson 4-6, Rational Numbers. Rational number is any number that can be written as a fraction of integers. In other words, a fraction of a whole number over another whole number, and the denominator cannot be 0. For example, some examples of rational numbers. 3 is a rational number because 3 can be written as a fraction of a whole number over another whole number because it's the same thing as saying 3 over 1. Okay. 2.5 is a rational number because I can change that to an improper fraction, which would be 5 halves, which is a fraction of a whole number divided by another whole number. 2.6 is also a rational number because that's the same thing as saying 2 6/10, okay, which can be rewritten as 26/10 if I wanted to rewrite it that way. Okay. Any decimal that ends or repeats in a specific pattern is also considered to be a rational number. Okay. Now, when writing fractions as a rational number, if you wanted to write them as a negative number, there's 3 ways in which you could write them. Okay, so there's 3 ways you can write a fraction that is negative. When a negative sign appears either in the numerator, the denominator, or the middle. If you look at the fraction negative 3/5 here, in this first fraction, the negative is on the 3, in the second fraction it's on the 5, and in the third fraction it's in the middle. It doesn't matter where that negative sign is, that fraction is still named as negative 3/5. I hardly ever see somebody go, it's 3 over negative 5, because it's 3/5, and it's not positive 3/5, but negative 3/5. We just call it negative 3/5. Now, most of the things we do with rational numbers happen to be with fractions and some decimals. So it's very good to become very fluent and fluid with being able to deal with fractions. The better you can deal with fractions, the better off you'll be and the stronger you'll be mathematically later in your careers. So, write 2 lists of fractions equivalent to 2/3. Okay? That's pretty easy. I could do this really easily. I could say, oh, look, 2 lists of fractions that are equal to 2/3. That's the same thing as saying negative 2 over negative 3, which is the same thing as saying, okay, I could list another fraction and I could say, I could decide I want to change my denominator. If I have 2/3, and I want to just multiply it by the same number on the top and the bottom, if I multiply both the top and the bottom by 2, I would get 4 over 6, which is equivalent to 2/3. I could decide I wanted to take that 2/3 and multiply both numbers by 5. It doesn't really matter what number I choose to multiply by. As long as I multiply the same number on the top and on the bottom, I will get an equivalent fraction. So I have 10/15 here. That's also an equivalent fraction. All of these are equal. Right? 4/6 is equal to 2/3, 10/15 is equal to 2/3, and negative 2 over negative 3 is equal to 2/3. All 3 of those are equivalent fractions. So, when it tells me to write 3 fractions equivalent to a fraction, I tend to make it as easy as possible. I multiply by 2, then I multiply by 3, things of that nature. If I decided this one here is 1/3, I could make them both negative, negative 1 over negative 3. I can multiply both the top and the bottom by 2. So 1 times 2 is 2. 3 times 2 is 6. I can decide to multiply both the top and the bottom by 3. 1 times 3 is 3. 3 times 3 is 9. All 3 of those are equivalent fractions. If I took 5/8, and 5/8, I can decide to make 5/8 both negative on the top and the bottom, because that negative divided by a negative is still a positive. Okay. I could decide to take my 5/8. If I multiplied everything by 2 over 2, that would give me 10 over 16. Or I could take 5/8, and I can multiply everything by, let's say, 3 over 3. That would give me 15 over 24. So there's 3 equivalent fractions there. Now when you have a negative fraction, it's actually much easier to write 3 equivalent fractions. I have negative 4/5. I can write negative 4 over the positive 5, or I could write positive 4 over the negative 5. And then the last one I could multiply by 2. 4 times 2 is 8, and 5 times 2 is 10. So there's 3 fractions right there that are equivalent to negative 4/5. And the last one, negative 1/2. I could put negative 1 over positive 2, or I could put positive 1 over negative 2, or I could multiply both the top and the bottom by 5, and I would get negative 5 over positive 10, or I could get positive 5 over negative 10. Or I could multiply it by 2, I'd get negative 2 over positive 4, or I could get positive 2 over negative 4. Look, how many equivalent fractions I have there. I have 6 of them, and it didn't even take me very much time. So writing equivalent fractions is not difficult. Just multiply this numerator and the denominator, the top number and the bottom number, by the same whole number, and you'll get equivalent fractions. Now, you can graph rational numbers on a number line just like you graph integers. The thing that you have to pay attention to is you have to learn how to label your number line. I am supposed to graph negative 3/4, 0.5, which is 1/2, 0, and 1/3. Okay? So if I'm looking at this, I'm like, how do I want to label my number line? I'm going to put this as being 0. I don't think I want to graph by ones. Okay, so maybe I'll make this one be 1/4, 1/2, 3/4, 1, 1.5. So going to the left side, not 1.5, 1 and 1/4, that was really terrible on my part. So I'm counting by fourths, I don't want to all of a sudden count by halves. I would have negative 1/4, negative 2/4, which is the same thing as negative 1/2, negative 3/4, and negative 1. So if I'm going to graph these points, remember to graph on a number line, you're just going to put in a nice dot on the number line itself. Not above the number line, not below the number line, but on the number line. So A and negative 3/4 would go right here. So I would put a dot there. You can put A above it if you'd like. That would be fine. Point B is 0.5, which is 1/2, so that would go right here on the positive 1/2. Point C is 0, so that would be a nice little dot here at the origin, so we got 2 point C. And D is 1/3. Well, 1/3, if you remember, 1/3 is a little bit over 1/4, but not quite the 1/2. So it would be between 1/4 and 1/2. So I'd put 1/3 there, and I'd put D above there. And I've now graphed all my points. Nice and neat. Now, if I wanted to put them in order, all I'd have to do is read my number line. If I read my number line, I now know that negative 3/4 comes first, then 0, then 1/3, and then 1/2. So if I wanted to put them in order, I can put them on a number line. You can do that very simply. Now, remember, a fraction bar is considered to be a grouping symbol. Okay? So that fraction bar tells you to do everything on the top of the fraction, and then everything on the bottom of the fraction, and then simplify the fraction. For example, a fast sports car can accelerate from a stop to 90 feet per second in 5 seconds. That's pretty good. What is its acceleration in feet per second, feet per second squared, in other words. And we're going to use the formula A equals F minus I, where I is acceleration, F is final speed, and I is initial speed, and T is time. So we're using this formula. A equals F minus I divided by T. A is acceleration. And it says, what is its acceleration? What is acceleration? So in other words, in this formula, we're going to plug in for A. And we're going to solve for A, excuse me. So A is going to equal F is the final speed. The final speed is 90 seconds. There's our final speed. So we're going to put 90 in for F. Minus the initial speed. What's its speed when it's at a dead stop? Hopefully 0 miles an hour, because if you're stopped, you shouldn't be moving anywhere. So that would be at 90 minus 0, all over T, which is its time in seconds. In this case, that would be 5. So we're 5. Now, according to the order of operations, it says do everything on the top, because essentially the fraction bar here tells you this and then this. It's kind of acting like little parentheses. Do the top first, do the bottom second, then do the simplifying of the fraction. So if I do that, I will have a fraction 90 minus 0, which is 90, divided by 5. A equals 90 divided by 5. And if I divide that out, I should get that my acceleration will equal 18 feet per second squared. because 90 divided by 5 is 18. So 18 feet per square second. That's acceleration. And that's just using a fraction and making sure you follow the proper order of operations, which is do everything on the top first, do everything on the bottom second, and then simplify your fraction. Okay. Now, let's do some more fractions. We're going to evaluate each expression with a being equal to 6 and b being equal to negative 5. And we're going to write them in simplest form because whenever you have the opportunity, you always reduce a fraction to simplest form. So a says a plus b divided by negative 3. So a is 6 plus b is negative 5, and we're going to divide all of that by negative 3. So do the top first. 6 plus negative 5 is 1. Divided by negative 3 gives us an answer of negative 1/3. Okay, it's already in simplified form. We don't need to do anything to it. For problem B here, we have 7 minus a negative 5. You do be careful with those negative signs. We have 2. 7 minus b, and b is a negative 5, so we have 2 negative signs in a row, divided by 3 times a, which is 6. Remember, a number next to a variable means multiplication. So 7 minus a minus 5 is actually 7 plus 5 over 3 times 6. 7 plus 5 is 12. 3 times 6 is 18. And we can reduce that fraction. 6 will go into 12 twice. If I divide by 6, I divide by 6. 6 goes into 12 twice. 6 goes into 18 3 times. So my final answer is 2/3. In our last problem here, a plus 9, so that's going to be 6 plus 9, all divided by b, which is negative 5. 6 plus 9 is 15. So I have 15 divided by negative 5, and 15 divided by negative 5 is negative 3. So there we have rational numbers. You've dealt with rational numbers for quite a long time. You probably just haven't named them rational numbers. Most people name rational numbers fractions, but they can also include decimals. So rational numbers are positive and negative whole numbers that can be written as a fraction of a whole number over a whole number. So you could have a decimal number if it translates to a whole number over another whole number. Or you can have a, for example, 1/3, that's a rational number. 0.3 with the bar over the top is also a rational number because that can be simplified to be 1/3. And this is rational numbers.